This is the electromagnetic train. It consists of a neodymium magnet here, 1, 2. Now this small one is basically used to ensure that it's stable, right, with the hole here, so that when it kept on a positive polarity here, so it's stable, it doesn't wobble. And then here another magnet. So this one now is a south, and this is a south, and then the positive is here, right? So this is a copper coil, right? Inside is empty. So when we put this in, right, there's a repulsion. So turn over the other side, push in, shoot out from here. Let's turn over, push this in now. Okay, do you know how does this work? To understand how this electromagnetic train works, so we have to first examine this neodymium magnet. It must be a strong magnet. So you can see that now this red is the north. You can see that this side is the south pole. The magnet here is the south pole, and the other side is also the south pole. So we created two south poles. So it can be both north. The traveling direction will be different or opposite, but if now it's south, and then now it's south, and then this is positive. So let's draw. Now I use the red to draw. So we have here south, north, and then we have a battery which is positive here. So this is positive, this is negative, and then we have another magnet here. Again, this is outside is south, this is north, right? So this is basically the diagram. Then we have a coil here. If you look here, it coils from here, go behind, then come down. So the wire comes down every time. So I'll use maybe blue. So it touch here, come down, 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 and so on, right? So this is the current direction coming down, right? So from here, from our Sec 4 magnetism course, we know that if the current comes down, this side will be north. So the magnetic field created by this electromagnet here will be in this direction here, inside here. So this is the magnetic field. Okay, so what we want to examine now is here, this part here, the magnetic field is strongest. Electromagnet, the magnetic field created by the electromagnet here is the strongest, here will be weak. So we examine this part. We have a north here, south, and then we have a north here and south. So if we look at the magnetic field here, the magnetic field will go out this way, right? And then here will go out this way at the center part. Then the magnetic field created by the wire, electromagnet, will be flowing in this part. So you can see that magnetic field will be coming in from here, trying to push. Here there's a repulsion force. When we look at the magnet, if it's north like that, and then there's another north here, you'll repel. But this wire, the magnet is sitting inside the wire, this wire cannot move. So what will move will be, there will be a pushing force here, very strong one here, to push this thing forward. But this magnet here is connected to this magnet by a battery, remember here? So when there's a repulsion, very strong repulsion force here, this whole carriage with one magnet, one battery, and one magnet here will be pushed outwards. Here there will be some contradiction here, there will be some attraction force, but here has a very weak magnetic field because it's outside the coil. right? Here also. So the strongest magnetic field created by the electromagnet is here. So this will create, the main force here will be a pushing force that push this forward, and hence this happen. So here, this is the positive, yeah, south. So when we put this coil here, the moment the wire touches this part, which is a conductor, the current start flow, and then you shoot out from there. If you want to push this in from here, you can't, because there's a pushing force that push it out. Unless you turn the other way, then you go from the other side. I hope this explanation is good for you.